In a universe that appears to be of infinite scale and numerous marvels, it's curious that the thing that interests us most is us. We are hunting for ourselves to find out that we are not on our own. Only 40 light-years away in the constellation of Aquarius is a small, dim star, TRAPPIST-1e. It's ancient, cold, and hard to see. Nevertheless, it houses something extraordinary. 7, not just 1, planets the size of Earth. It is as though nature's own experiment was set up. Can life exist in the vicinity of such a star? At first, the majority of scientists ruled out these worlds as if they could be inhabited, too hot, too cold, with no atmosphere and no chance. However, there is still hope for one world, TRAPPIST-1e. And now, as a result of data from the James Webb Space Telescope, we may finally be able to see its atmosphere. What we've discovered is astonishing. Is this the first instance of a planet similar to Earth outside our solar system? Could TRAPPIST-1e host life? Today, join me on our journey to the TRAPPIST system, an exploration of the potential for life when it is at its best. We'll look at brand new data from the James Webb Space Telescope, pushed to its limits, and examine the likely composition of TRAPPIST-1e's atmosphere and whether it could support life. That is, if the star itself provides a chance at life and hasn't also handed down a death sentence. TRAPPIST-1e is a red dwarf of the M8 class, insignificantly larger than Jupiter. It is about 1,800 times less bright than our own Sun, a distinction similar to comparing a candle to a stadium floodlight. Since its discovery in 1999, the full planetary system wasn't revealed until 2017, when TRAPPIST became the first and only robotic telescope-discovered system of its kind. The telescope array has two parts, TRAPPIST South in the mountains of Chile and TRAPPIST North in Morocco's Atlas Mountains. They use a method called transit photometry, measuring dips in a star's brightness as planets pass in front. At first, only 3 inner planets were detected, but further observations, including from the Spitze Space Telescope, increased the total to 7. All are rocky and roughly Earth-sized, making this the most Earth-like planetary system yet found around a star. But could they be habitable? To receive enough energy for life, planets around such a dim star must orbit extremely close. The TRAPPIST-1 planets do. Each one is incredibly near the star. TRAPPIST-1e orbits at about 1/113th the Earth-Sun distance, likely tidally locked, always showing the same face to the star like the Moon does to Earth. This has major implications for habitability, which we'll explore. Crucially, TRAPPIST-1e lies in the middle of the star's habitable zone, receiving roughly 1/3 the sunlight Earth does. Light alone isn't enough. It also needs an atmosphere. Researchers have searched using James Webb. They have already ruled out primitive hydrogen-helium atmospheres for some planets, and TRAPPIST-1e's early results were fascinating. There is no dense Venus-like CO atmosphere and no thin Mars-like one either. This is good news. Those environments are hostile to life as we know it. Instead, an Earth-like atmosphere remains possible, dominated by heavier gases such as nitrogen, with greenhouse gases like CO, methane, and water vapor at Earth-like pressures approximately 1 bar. Such an atmosphere could distribute heat to the dark side, potentially allowing global oceans even under tidal locking. A 2025 study led by Anna Glidenetmit, published in astrophysical journal Letters, analyzed JWST data suggesting a nitrogen-methane-rich atmosphere with little CO similar to Saturn's moon Titan, but warmer. NASA and the Space Telescope Science Institute concur that this keeps hope alive for a water-bearing world, although the data slightly favors a cold planet without a global ocean. A methane-rich atmosphere under a cool, infrared bright star like TRAPPIST-1 would absorb starlight before it reaches the surface, creating an anti-greenhouse effect. Surface water might exist only on the star-facing side, but even that could be enough for life. Darwin spoke of a warm little pond, and TRAPPIST-1e may offer one. Atmospheric modeling supports this. Simulations show that even with limited water or waterlocked on the dark side, TRAPPIST-1e could maintain a stable atmosphere. This might lead to Terminator habitability where life exists in a twilight band between day and night. But surface water isn't the only option. TRAPPIST-1e is rocky. It could be an icy volcanic world with a subsurface ocean like Europa or Enceladus. Some believe life on Earth began near deep-sea vents. The same could happen on 1e, wherever water exists on TRAPPIST-1e, life is possible. There's an energy source and potentially an atmosphere with life's building blocks. But one issue remains. Scientists can't yet rule out TRAPPIST-1e being a cold, barren, airless world. So, what could prevent a stable atmosphere from forming? The culprit is the red dwarf star TRAPPIST-1 itself. Imagine standing on TRAPPIST-1e. Look up. The star appears over 4 times larger than our sun. A deep red, orange casting a perpetual sunset glow. Red dwarfs are highly active, producing powerful flares more often than the sun. The worst geomagnetic storm to hit Earth was the 1859 Carrington event, a once-in-a-century event. TRAPPIST-1 likely releases a flare this powerful more than once every 2 days. You could watch solar flares arcing into space in real time. These carry immense energy, potentially stripping away any atmosphere over time, making life impossible. That assumes an atmosphere ever formed. Red dwarfs are incredibly long-lived. TRAPPIST-1 is expected to shine for 10 trillion more years, 700 times the universe's current age. Our sun has only 5 billion years left before becoming a red giant.